Good afternoon, math students. Today we're going to be talking about 8.4, which is comparing two linear functions. So again, we're writing things in y equals mx plus b form. We're probably going to be comparing the rate of change or the slope and the initial value, which is also known as the y-intercept. The first one on the launch, we've got the city's second best scientist knew that his robot Blue was too slow to beat robots Red in a 100-yard race. So he rigged it to make it end in a tie. So if you'll notice, robot Red starts down here at 0 and steadily increases, where robot Blue starts at 50 yards and decreases or increases a little bit slower. How was the race rigged? Well, obviously Blue got a head start. It got to start 50 yards ahead of Red, where robot Red started back here at 0, 0, the starting point. Now, how could we compare these, or how much faster than robot Blue does robot Red run? So you're looking at the rate of change. You're looking for how many yards per second does each robot go. Blue, if you'll notice, goes from 50 to 60, which is up 10, the rise is 10, over a run of 2 hours. Again, up 10, 50 to 60, and then over 2 seconds. So up 10 over 2 is a rate of 10 divided by 2, 5 yards per second. Red, however, goes from 0, 0 up to 10, so it's also increasing 10, but going over 1 second. So 10 divided by 1 is 10 yards per second. Therefore, the red robot runs twice as fast as the blue one, or you could say 5 yards per second faster. Either way, you're looking at the rate of change. Obviously, the red line is steeper, so it's going faster than blue. So when you're looking at comparing the graphs of two linear functions, you're looking to see, do they intersect? Where do they start? What about the rate of change? On this graph, it shows the rate of change of 1, that's the blue line, and the second graph is the rate of change, which is negative 1/4. Obviously, the blue line has a greater rate of change because 1 is greater than negative 4, so it's steeper. Besides, the yellow line is totally negative. Over here for the pink and orange lines. The pink line has a greater rate of change because it has a slope of 2. The orange line is a little bit flatter because it has a slope of 1/3. Therefore, pink is greater because 2 is greater than 1/3. So as you're starting to pick up on, hopefully, the bigger the number, the higher the rate of change. For the first example, and the complete the part 1 got it, we're talking about two different towns here and how their temperatures change throughout the different parts of the day. For Funtown, at 4 p.m., the temperature was 70 degrees Fahrenheit. Between 4 and 10, it decreased by 2 degrees per hour. Schuster, however, gave us the function t equals 72 minus 2h, where t is temperature and h is the number of hours, which I also wrote down here for you. So the first thing we're going to do is write these equations to help out. Now, obviously, Schuster's already done for us, but we're going to manipulate it just a little bit. So for Funtown, the temperature starts at 70 degrees, but then decreases. So that's very important. You put that subtraction there at a rate of 2 degrees per hour. So 70 would be our initial value, and negative 2 degrees is our slope. I would totally rewrite this if I were you. T equals negative 2h plus 70. Notice the 2h stays negative because it's being subtracted. It's a decrease in amount. It's a negative slope of 2 degrees per hour. Now that these are done, you can go down here to Schuster and see that temperature equals 72 minus 2h. Oh, they gave that right there. And I'm going to rewrite that one as well. So when I go to rewrite that one, t equals negative 2h plus 72. Again, the negative 2 stays the negative with that minus sign out in front because it's decreasing at a rate as well. Now it says what function has the greater rate of change, which one? Well, actually their rates of change are the same. Both of them have negative 2 degrees per hour. So the rate of change is the same for both towns, for both functions, which means that the temperature drops 2 degrees per hour in both towns. For the next example, part 1 got it. So kind of check to see if you guys have been doing okay with this. We've got 3 towns this time: Eastbury, Hilltown, and Topperville. In Eastbury at 8 o'clock, which looks like it's the starting temperature, the starting time for each 3 towns, The temperature was 62 degrees Fahrenheit between 8 and noon. Then it increased by 3 degrees per hour. So what we're going to do is temperature equals 62 as our starting temperature plus 3 degrees per hour. Again, highly recommend rewriting it in slope-intercept form where the temperature equals 3 degrees per hour. It's positive because it's increasing, plus the 62 where it already started. That's for Eastbury. Hilltown shows us a chart. That's okay. We can work with functions from charts and tables and graphs. It's all good. And from the equation. This is the starting piece right here, that 8 o'clock start time. So temperature equals 62 degrees at 8 o'clock start time plus 2 degrees per hour. How did I get the 2 degrees? Y over X, which is what a lot of you kind of messed up on that last quiz. Make sure it's Y over X. It's increasing. Each temperature is increasing by 2. Hours are increasing by 1. 2 divided by 1 is 2. So 62 degrees starting temperature plus 2 degrees per hour. Rewrite it as 2H plus 62. So we've got 2 of the 3 done. Luckily, Topperville gives us the equation. T equals 54 plus 2H. Rewrite it. So you're switching it around so slope comes first. 2H plus 54. The questions say, what will be true about Eastbury and Hilltown? Well, their lines will both start at 62 degrees. Eastbury started at 62 degrees at 8 a.m. and as well did Hilltown. At 8 a.m. it starts at 62. So both lines will start at 62 degrees on the y-intercept, or the y-axis. Now, Hilltown and Topperville, hopefully you picked up on the changes we are going through. Both of them have a rate of change of 2 degrees per hour. So kind of like how we talked about in class on Wednesday, Hilltown and Topperville will be parallel lines because they have the same slope or rate of change, which is 2 degrees per hour. Moving on to the second got it. We've got 2 towns again, this town, Funtown and Schuster, and we're just focusing on writing those equations once again. Funtown looks like 4 o'clock is our go time. Town starts at 70 degrees, but then the temperature drops by 2 degrees per hour. And I forgot our negative sign in there. So make sure you put a little negative out in front right there. So T equals negative 2H plus 70. And over here, Schuster is negative 2H plus 72 because their function was already given to us. Schuster has the initial value higher than Funtown's because it's at 72 degrees and Funtown is over here starting at 70. So the initial values, Schuster has a higher initial value. Now compare this. What can we conclude about the situation? Well, Schuster's starting out a little bit above it, but at the same time, their rate of change is both 2 degrees. Just going to go back here and try to add that negative there. Schuster's temperature was 2 degrees warmer than Funtown's at 4 p.m. That's what we can conclude from that situation. Again, guys, sorry about that. Make sure you put a negative in front of that 2H. So what can we conclude about their initial values? Well, Schuster's temperature was 2 degrees warmer than Funtown's at 4 p.m. because it started at 72 and Funtown started at 70. Next thing we're going to look at is Larry and Melissa and talking about their bank accounts and summer jobs when they have money. Larry saved $600 from his summer job. So the starting amount that Larry has is $600. Then he withdraws $15 from his account each week. I don't know if you realize it or not, but a withdraw means that you're taking money out of your account. If you were to deposit, you'd be adding money in your account. But Larry's taking money out. In fact, he's taking out $15 each week. Right there, that should clue you in that the slope or rate of change is negative 15. So Larry's function is going to be y equals 600 minus 15x. Or you can rewrite it as y equals negative 15x plus 600. Either way, I recommend this way because it's in slope-intercept form. That's great. Now what about Melissa? Melissa over here, it doesn't exactly say what Melissa started with. We don't know that information, but we do know that she is taking out $10 per week. 570 to 560 is subtracting 10 divided by the change in weeks, which is 1. Negative 10 divided by 1 is negative 10. So I'm going to write her equation as y equals negative 10x plus. I'm going to leave that blank. Really don't need to know it, but I don't know what her starting amount was. Now, if you wanted to, you could work backwards and kind of figure that out. So most of you are sitting there thinking, oh, she started with 580 because we would add 10 back. But that, again, that doesn't matter. So y equals negative 10x plus whatever. The question asks for what do the absolute rates of change tell us and which one has the greater absolute rate of change. In most cases, we know that negative 10 is greater than negative 15, but that's not what we're talking about here. We're looking for a steeper line. So when you're talking about the absolute range, it's going to be Larry. $15 per week is greater than Melissa's $10 per week withdrawal. So Larry's function has the greater rate of change. His line is going to be steeper, even though it's negative, because 15 is larger than 10. That's what they mean by the absolute rate of change. For the close and check, just kind of putting everything together, circle the two linear functions of the lines that do not intersect. Well, if we don't want them to intersect, we know that they have to be parallel. So in order to be parallel, they have to have the same slope. Both of these have a slope of 1/4. Doesn't matter what the y-intercept is. What matters is the slope is 1/4. This one has a slope of 4, and this one has a slope of -4. Those are different. Those are going to intersect. Question number 2 asks which two lines have the same rate of change. Line 1 and line 3 are going to have the same rate of change because they're parallel. Question 3 says which two lines have the same initial value. Both 2 and 3 both start from 1. And I accidentally put 2 over there. So both of them start at 1. Put a 1 right there for me. If you keep going, I did a review solving equations problem for you. If we have 4 times the quantity x plus 3, you have to multiply the 4 through, which is called distributing. 4 times x is 4x, 4 times 3 is plus 12. Set it equal to 60. This is a two-step equation, which you should remember how to do. The opposite of add 12, subtract 12. Now remember, I can't combine these two together right here because one has an x on it and the other one doesn't. So I've got to get this 12 to the other side with the other numbers. Subtract 12 from both sides. The 12s cancel. We're left with 4x equals 48. Divide each side by 4. 48 divided by 4 is 12. Hopefully you're having a great day and you're being good for Mrs. Allen. If you have any questions, don't hesitate to ask Mrs. Allen, a classmate nearby, or feel free to email me as well. Looking forward to seeing you back tomorrow. Bye.